Let's take a look at the properties of ionic and covalent compounds. When we're talking about the properties, we actually refer to the boiling melting points, the electrical conductivity, as well as the solubility of these ionic and covalent compounds. So let's take a look at determining the boiling points and melting points of ionic and covalent compounds first. Now, I find it easiest to remember this by looking at the structures of ionic and covalent compounds. So on the left here, you would see a cage-like structure. This cage-like structure is unique to ionic compounds. This structure, you need to know its name. It's called a giant lattice structure. If you look at the diagram, you would see this is trying to depict the ionic compound sodium chloride, where you have every sodium atom bound to a chloride atom, a sodium ion bound to a chloride ion. And if you look at the type of bonding or the type of lines between all of these ions, these are very strong and these are all bolded lines, right? So this actually gives us a hint that the forces between all of these ions, these are very strong. It is like a cage that is sufficient enough to even lock a tiger inside. Okay, so these are very, very strong bonds in between the ions. So when it comes to the boiling point and melting point of ionic compounds, we would say that it is very high. Why? Because you actually need large amounts of energy required to overcome the strong electrostatic forces of attraction between the ions. So it is very important for us to remember this phrase, electrostatic forces of attraction between ions. These refer to all of these blue bolded lines that I'm highlighting now. So during boiling and melting, all of these bonds have to be broken. And in order to break all of these very strong bonds, you need strong energy or high amounts of energy. That's why they have high melting and boiling point. What about for covalent compounds? For covalent compounds, if you take a look at this diagram here, in between each of the covalent compounds, so this is one covalent compound, 2 and 3, in between these covalent compounds, there's actually only very weak intermolecular forces, right? So during melting and boiling, very little energy, or we can say little energy or less energy is required to overcome the weak intermolecular forces of attraction between the molecules. Okay, so remember, between all of these covalent compounds, there's just all these very weak bonds. So in order to break them or overcome them, you just need very little energy. Hence, the covalent compounds have low boiling point and low melting point. Now, for the second property, can the ionic compound and covalent compound conduct electricity? To be able to conduct electricity, right, basically you need something to carry the electrical charges. So this can exist in the form of either ions or electrons. So in ionic compounds, yes, ionic compounds can conduct electricity, but only in molten and aqueous state. What does that mean? So if you come back to the giant lattice structure, this is how the ionic compound will be in the solid form. However, if let's say it is being melted, or we can call it melted means like molten sodium chloride, or if we are talking about sodium chloride being mixed with water, then what would happen is that all of these sodium and chloride ions, they will just be freely floating. They are no longer going to be held in this regular cage that is the giant lattice structure. Okay, so only in the molten and aqueous states there are free moving ions present. However, in covalent compounds, they are not able to conduct electricity in any state. Why? Because there are no free moving ions and electrons. Okay. With regard to solubility, you just got to memorize this, okay? So for ionic compounds, it is soluble in water, Whereas in covalent compounds, right, it's the opposite of the properties of ionic compounds. That means it is soluble in organic solvents, but insoluble inside water. Okay, you might be wondering what organic solvents are. So you would encounter these again in organic chemistry, but basically you can simply think of it as oil. Okay, so this is the properties of ionic and covalent compounds.